Let's see if that works. All right. So today we're going to talk about logarithms. First thing we're going to do is we're going to graph a logarithm without even knowing what the hell it is. But not really. We know a little bit about what it is. So if I give you the function, and this is 14.3, 3 to the x, I can graph that relatively easily, right? How do I graph that?
0, 1, 0.
Good. So for any non-shifted exponential function, it's going to go through the point 0, 1, because something to the 0 power is 1.
1, 3.
Yeah, it's going to go through 1 base, 1, 3. It's going to go through negative 1, 1 over base. Cool, so that's 3 to the x. It's amazing. Now, without even knowing what it is, I can graph the inverse function. So we're actually going to graph the inverse function first, just because we can. And then we're going to actually determine what that inverse function is. And, well, we'll see how this. How do I graph the inverse function? So I know that this function, f, goes through negative 1, 1/3, 0, 1, and 1, 3. So what's f inverse going to go through?
1, 3.
Oh, that so sucks. That's what I get for leaving my mark reading. Yeah, it's going to go through who?
1/3.
1/3, negative 1,
1, 0.
1, 0,
3, 1.
3, 1. Cool. Like it.
I have a marker.
What's up?
I have markers.
Yeah, Dan stole my marker. Hey, look at that. Thank you, though. I appreciate that. I thought they were dead down there, but they are alive. So now if I, let's see, 1/3, negative 1. You see that? Is that cool? 1/3 on the x, negative 1. 1, 0. And it kind of makes sense. See that reflection idea, right? If I go this way, it's a reflection. You guys kind of with me still? Okay. And then 3, 1. 3, 1. That's the reflection of that one. Where do you think the asymptote is? The asymptote used to be...
X-axis.
Yeah, kick ass. The asymptote used to be y equals 0. I don't know if you guys realize. Another name for the x-axis is y equals 0. Because what's true about every point on the x-axis? So a name for the y-axis is? X equals 0 is crazy. So why does it make sense? When I do an inverse, all the x's and y's switch. So it only makes sense. If the asymptote used to be y equals 0, now it's x equals 0. And you can kind of see that here. That's the point that's getting really close. So it's going to be... Make that big. So there you go. Kick ass. This is going up forever. It goes to infinity, but it goes stupid slow. It goes slower than any root. It goes slow. Anyway, because this goes really, really, really fast, and this is the opposite function, so it's going to go to infinity really, really, really slow. The reason I say that is, be really careful. I know it seems like I'm being picky, but if you do this, then you don't understand. I mean, that's making it look like it's going to turn back around. It's going to have another x-intercept. It looks like a down parabola. No, it should always be going up just very slowly, like a rattle. All right, cool. I like it. So do you understand what we just did? We graphed a function that we don't even know what the function is. It's the inverse of this, sure. All right, you guys still with me a little bit. So nothing major yet. All right, now the main reason logarithms are difficult for people is because you're not used to it. So we are more used to this. What's this? Are you the one I thought worked good? Yes, sir. Okay. You do yours. What is that? That's crazy. Are you better? No, you're not even existent. All right. That's 3. Why? I love it. Kick ass. You said exactly what you were remembering. 3 to the third is 27. So this, we know what this question is. We understand what that question is. What do I mean by that? A symbol is a question in math. It's asking me, and I think I said this to you when we talk about radicals. As long as you know what the symbol is asking, you know how to attack the problem. And that's the problem with logarithms. People don't understand what that symbol is asking you. So this is related to x cubed equals 27. What do I cube to make 27? And we all know that's what the question is, right? Is that cool? All right. So this function, all we know right now for that function is that if this function is y equals 3 to the x, how do I write the inverse function? What's the first step? Switch the x and y, right? So all we got so far is this. That is unsatisfactory. It's like not having a way to rewrite this. I don't want to have to write x cubed equals 8. I want to be able to write cube root of 8. Attack the 8 directly. I don't want to have to write a little equation every time. I want a symbol that means what that equation means. You guys got it with me? A little bit? All right. So all that's missing here is a symbol to mean what that says. So for example, if my x were 9, what would my output be? What would y have to be? 2. Okay. All right. So I could say I want the symbol for this to be box. Yes. It's not. And then I say, well, if I put a 9 in there, that means 3 to what power is that? And the answer would be 2. So no, that's crazy. That's silly. Right? Whoever said that, they threw him out of the room. And unfortunately, the person they listened to said, why don't we use part of the word logarithmos, study of numbers, why don't we use a little part of that to be the symbol? And everybody, for some reason, they were all high or something. And they said, sounds good. So what this means is if you give me a number, I'm asking you, what do you raise 3 to get it? So that's exactly what this symbol here means. If you give me a number, so what this is the part of the word logarithmos. So they just use the 3 letters. Thank God you have to write logarithmos out. Right? It's a friend of Spartacus. I don't know. And the base is the base. So if I put a 4 there, it would be asking, what would you raise 4 to get this? Right? So this would be represented as log base 3 of 9. That's how you would say it. And what question is that asking you? What do you raise the base to? What power do you put on the base to make it this number? So of course, what do you raise 3 to make it 9? To the second power. So the answer to a log will always be a power. Do you see how slowly I just said that sentence? Do you see how I normally talk really fast?
Say it one more time.
Yes, this is a good note to take. The answer to any log will always be a power. That's stupid important because we're going to talk about the properties of logs today, which amazingly enough, the properties of logarithms are exactly the same as the properties of powers because logs are powers. Holy shit. All right, let me back off of that for a second. I want to make sure everybody is with me on this. And this is really all it is. This is really all it takes to understand almost any freaking math. If I showed you a calculus book right now, you wouldn't know shit about it. Not because you're not smart, but because nobody told you what the symbols meant. Just like if I gave you a book written in Yiddish. Some of you guys might know Yiddish. Anybody? Esperanto. Anybody watch the William Shatner movie all in Esperanto? No? Did you guys know there was one? No. You guys know what Esperanto is? All right, Google. You got Google. You wouldn't know how to read the damn thing, not because you're stupid, but just because nobody told you what the words mean. Shit. All right, so if I ask you, let's see. So if I ask you, what is log base 4 of 16, what question is that asking you? What do you raise 4 to get 16? So the answer, of course, is 2. Kick ass. Right? That's all logarithms are. That's all. That was awesome. It was a little punctuation. All right. So what about log base 8 become an 8? 8. It's almost too easy. 1. Yeah, you raise 8 to the first power to make 8, right? So what about log base A of A cubed? 3. Almost too easy, right? And don't forget, how does log base something relate to something to the power? How are these related? How are these related? Logarithms and exponential functions. How are they related? They are inverses of each other. So watch this. Not only is this stupid easy because it says, what do you raise A to get A to the third? Well, you just told me it's 3, right? But also, these kill each other because they're opposites. So of course the answer is 3. Let me see if you guys understand what I just said. So what is 9 to the log base 9 of W? So you guys will understand what I just said. It's W. Because what does 9 to a power, what do these do to each other?
Cancel.
They cancel. So the answer is W. And let me say this a different way. If you understand that, kick ass. Well, let me. I always try this. Someday, I'll get people to understand me. Let's see. What does this represent? What is this by itself? You can't figure out what this is, right? Because what does it represent? I'm sorry. Yes.
Is the base of that log raised to the W power? Is that how it's written?
No. It's log base something of something.
Okay.
So it's not that to that power.
Log base 9.
Log base 9 of W. So like log base 9 of 81 would be 2 because 9 squared, you can always draw these little arrows, right? 9 squared is 81. I like it. Okay. So what does this represent? What does this represent? Why is it 2? Because this represents the power that 9 needs to become 81. So what does this represent? The power that 9 needs to become W. So when you give it to 9, it becomes freaking W because that's what it just said, right? I know people don't like this too bad for me. Because it's so much easier to just go, well, these cancel. But it really is cool. That represents the power that 9 needs to become W. So when you raise 9 to it, it becomes W. Because that's what the hell it does. But there's nothing wrong with just saying they cancel. There's nothing really wrong with that. It's beautiful. Nothing wrong. Yes, sir?
With a different number in front other than a 9.
Oh, then you couldn't do anything. So it was 4 to the log base 7 of T. You're like, all right, that's it. It's sort of like if I said, it's related. Logarithms are kind of related to radicals in a lot of different ways. They are not the same thing. Otherwise, why would we do this to ourselves? We wouldn't need logs, right? Okay. And there are stupid math jokes about log cabins and shit, believe me or not. Right. I will not tell you more than that. I don't want to own up to them. All right, let me give you a few more of these, just the basic ideas. More logs. Here, you guys try these. Don't say anything out loud. They give you some nifty ones. Alright, the last two should be neat. 3? Yes. Yeah, I don't like the number 3. Singers have notes they don't like to try to hit. Well, everybody. For me and my profession, it's number 3. The first two should have went pretty quick, I hope. And the last two, maybe they did too. This one is, of course, what?
27.
4.
So real quick, it can't mean something else that exists already. So this cannot mean division, because that exists already.
4 3 6 1.
Yeah, logs have to be their own thing, or else why would we have them? So again, the question is how many 3s, so another way to look at it, how many 3s have to multiply to make 81, which is the same thing as what power does 3 need to become 81 is 4. Because 4 3s multiplied by 81. If you're not sure, you can just break it down, and that's the relationship between logs and radicals. If I give you a hard problem with a big ugly number, you just start breaking it down to analyze it. It's not the same thing as radicals, but you can look at it in the same way. That's 4. 3. We saw one earlier today. It was a cubes with 125. It's 3 5s make 125.
1/3.
Good. So this is interesting. If this number is smaller than that number, but not smaller than 1, the answer is going to be a root. It's going to be a fraction, right? Because you apply a root to this to make it smaller. So I have to do the cube root of 27 to make it 3, which is a 1/3 power. How do you feel about that? Is that all right?
Isn't 20? Oh, wait.
Now, real quick, let me write below this 2 other things. What's log base 27 of 1?
0.
No.
1 over
Yes. What do you raise 27 to make it 1? What do you raise anything to make it 1? 0. Right? Oh, shit. And what's log base 27 of 1/27? Don't overthink it. What do you do to 27 to make it 1/27? So you...
-1.
Yeah, -1, because you're supposed to flip it. So now watch, real quick. Now stay with me. Do you have to understand what I'm about to say? No. But if you do, you're so much further along. See this number? It's bigger than 1, but it's smaller than 27. So the answer will be a fraction. It'll be a root. That's how I cut things down, is apply a root. If I want to make something 1, I have to give it a 0 power. So of course, if I want to make it less than 1, I have to give it a negative power. Do you see how that works? Maybe? Do you have to know that to do these problems? No. Well, that's kind of a good observation to make. So then I know number 4 is less than 1. It's got to be a negative power. I've got to flip it. I've got to flip it and... No? Yeah, square. So I square 4 to make it 16, and then I flip it to make it 1/16. So I got to be a -2 power. So all you do there is, whatever that is the negative of it to make it flip. I like it. See, I desperately want you... There's no reason that logarithms should be hard. They're not. They are not difficult. They're not. Okay. Oh, I think maybe I've got all you with me. So, that's 14:3. Make sure I didn't miss anybody. Oh, one other little skill that I haven't really shown you directly yet is rewriting from exponential to logarithmic. It's sort of like if I said 3 cubed is 27, I can rewrite that as 27 to the 1/3 equals 3, right? So there's 2 different forms of the same idea. Are you guys kind of with me? Do you understand those both represent the same kind of idea? Just inverses of each other, right? So if I have log base 3 of x equals 2, how can I rewrite that in its inverse form, in exponential form in this case? What does this mean? 3 to the second power equals x. So then I can solve. I sort of have a little equation, and I can solve it. I just did. What's the answer? Crazy. That's crazy. Of course, equations are going to get a little bit more difficult than that. But that's an equation I can solve just by rewriting what they gave me in its alternate form. Alright, going this way is easier, because I just take the base to the power is this guy. Right? And see how these are inverses? What's the input here? Let me see you guys. What's the input here? What's been input? What's the function here? Let me say this. What's the function? What's the function?
Square root of 81.
Square root. So what's the input?
81.
What's the input?
No.
9. What did I put in to the function? I put a 9 into the square root, right? So the function here is log base 3. What's the input?
2.
That's the output. X is what did I put into the log? X. And what did I get out? 2. Now here, do you see how the input now is 2 and the output now is X? Right? That's the idea of inverse functions. Are you with me? One guy's input is the other guy's output, and vice versa.
So it's their inverse.
Yeah, this is the inverse relationship.
It does the same thing though.
They mean the same thing, but in this alternate form, I actually got the answer. Cool, I like it. So now going the other way is a little bit trickier. If I have a to the b equals 3. Now let's see if we can piece this together. How do I go back? How do I make it into log form? Well, what's the base? Where does that go? In the base. Does that make sense? I like that. The base goes in the base. Log base A of what equals what?
3.
Good, because the output should be the power, right? And so the 3's got to go there. The input is now the output is now the input. And how do you check yourself? A to the b equals 3, that's what I have. Tick S, because it's easier from log going back. So that is a little skill. The homework is going to have several of those, and I'll have several of those on a test or a quiz in the future. Ruh-roh. All right. So let me one more of these that's a little more challenging. I'll show you kind of an alternate way to solve this. Can't figure it out. Does anybody have the answer? Yeah, square root of 8 is not 4. All right, so the answer can't be 1/2. If this was a 2, why would that be easier? What's log base 8 of 2? What's log base 8 of 2? 1/3, because this cube root of 8 is 2. 1/3. All right, Jeff, why did you say it like that? Log base 8 of 4, well, 4 is 2 squared, so it should be 2/3. If I cut 8 in thirds, right, the cube root of 8 is? The cube root of 8 is 2, and then I square that to make it 4. Oh shit, so let me show you a little different way to do that. All right, you should be able to do it that way. This number is less than 8, therefore, and it's not smaller than 1, so it must be some kind of a root. But there's also a power involved. Remember the root's on the bottom? Power's on the top. So what do you have to apply to 8 to make it 4? You have to apply a cube root, 3 on the bottom, and then square it, 2 on the top. Bam. Right? The other way, become the word other. The other way to do this is, what's the answer? I didn't know. Let me call it x, because I don't know what the hell it is. How can I rewrite that?
B to the x equals 4.
And then now you're like, thanks, Jeff. But how can I write both 8 and 4 in terms of the same base? What base do they have in common? Does that make sense, the question? They both have what in common? What base? 2. 8 is 2 to the third power. And 4 is 2 to the second power. You guys got it with me so far? So what do I do here?
Powers.
Well, it's like you take the. Right?
Three
It's like
X
the.
equals.
Well, no, just right here, what do I do with this? Multiply. So it'll be 2 to the 3x equals 2 squared. These are both 2. So what must be true about these in order for the equation to be true? They must be equal to each other. So 3x must be 2, right? 3x must be 2 for this to be true. And when you solve for x, you get 2 freaking thirds. So if you can make these the same base, it's easy to do. If you cannot make these the same base, well, that's section 14.6 or something. All right, we're getting there. All right. Blah, 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 blah. Let me see. Anything else in there? No. Cool. Oh. I don't know. We can take a break if you want to. Want to take a break? Yes. Okay. We'll take a break. When we come back, we're getting to 14.4. Who didn't get their test back? Anybody?